So this is, as Melanie very rightly suggested, a very up-to-date, hopefully, piece of research. And actually, I am doing a similar research about democratic debates as well, where I am looking at the emotions of candidates. So today, it will be the presidential version of analysis of emotions. Okay, so what I'm doing is basically, in a very small nutshell, is something like this. Right? I am extracting pieces of information from presidential debates, and presidential debates has different sources of information. So one source is image, another source is voice, the vocal data, and the third source is text. I'm extracting all these sources of information, and using a probabilistic model, I'm classifying the emotion that exists in those sources. So if you capture frames like you do here, you can attach some probability to the emotion in the frames. As you can see here, we have Hillary Clinton and on the left-hand side and Donald Trump on the right-hand side. Hillary Clinton is, the probability that she has fear is 60.3%, around 60.3%, and that she surprises 31.4%, and then some smaller probability levels for the rest of emotions. So the result of this classification, for instance, that is on the left-hand side is fear. Right? So it doesn't matter how large the probability is, but the majority takes all principle also works here. So fear is the emotion there. And on the right-hand side, we see a surprise emotion. Okay, so what is my motivation to do something like this? This is actually a type of research that hasn't been done by a lot of people, at least in political science. The biggest motivation was to classify emotions in presidential debates in the US because it's a big event not only for the US but also for the whole world. And to test some theoretical claims like emotions have become more prevalent over time. People track emotions of elites and use this perception to complement their understanding of the elites, right? How they respond to the elites in elections. Background, why emotions? So this is the motivation. Right? Emotions are very central to politics, but they are very much understudied. So for example, people take advantage of emotions when they're reporting things related to foreign policy like terrorist attacks to gain support in their own country. People use footage to collect donations. People use all different types of rhetoric to build nationalism, right? There's a lot of emotions involved in all those actions. And then they can be important to understand the motivation behind what decision makers do, what elites do, what politicians do. So in literature review, there's not that much. Emotion is implicit, but under-theorized, right? Emotion is mostly seen as deviation from rationality, so people think that it's something that shouldn't be studied at all, right? And mostly emotions, the emotion studies, emotion research, is reserved for psychologists, right? They are working on how to classify emotions, what is an emotion and what's not an emotion, but no one so far, at least what I have seen, has done an empirical study that quantifies emotions. Emotions are seen ephemeral beings. There are methodological concerns in terms of measuring emotions because it's not very clear what is an emotion and what's not an emotion. People can fake emotions, right? They're hard to define, hard to measure, hard to operationalize, hard to put into context. And realism and liberalism rest on the fundamental assertion that the behavior of states is based on rational and intelligible factors, not the emotions of public, and how this emotion is perceived by the elites, or vice versa, how the emotions of elites are perceived by the public, right? People think that it doesn't depend on those things. So in the light of this, lack of research, hopefully, which is a good thing, for a good basis for writing a paper, right? I asked some research questions. So one of my research questions is, after I quantify all the emotions, and I will explain how I did that briefly in the coming slides, I look at whether some debates are emotionally closer to each other. And the specific question that I ask is, are temporally closely located debates taking place in the same decade, for instance, also emotionally closer to each other? Is there a zeitgeist to all of this? Have the role of emotions in presidential debates increased over time? Are people more emotional compared to 70s? So the first presidential debate was in the 70s, 76. So I have only data starting from the 70s That's the earliest. Do presidential emotions have an impact of elite perception? So if presidential candidates show some particular signs of some emotion, does elite respond in some way, right? Is there a correlation there? How are presidential emotions related to public sentiment? If, again, presidential candidates show some particular emotion, does that affect the share that they get in the elections? So this is the first section, the first 4 questions. The second section looks at the YouTube data and the comments that people left for presidential debates on YouTube. And I look at the connections between different presidential debates based on who left what comment on YouTube, and look at the fact whether there are some debates that are strongly connected to each other. And I will explain how I did that. So data is quite large because of the nature of image and video data. You have a lot of information. Even if you have one video, it's a lot of information. So I'm looking at 29 YouTube videos. So those are presidential debate videos that I extracted from YouTube using YouTube Wrapper. And as I said, the first presidential debate was in 1976, and the last one that we witnessed was in 2016. So that is around 40 years of data. So I look at 29 videos, and I extract video, audio, and text from those videos. I do face labeling for each person that appears in the video. Then I look at state and federal level endorsement data. I have data on that to test elite perceptions. I'll explain again in more close detail. And I also look at over 27,000 YouTube comments to set up my network analysis model. Okay, so to look at methods a little more closely, the first thing that I did was extracting emotions from faces of people, so the faces of people that we see in the videos. What I first do is do a face matching. So first I identify who is in the video. So I exclude moderators and people from the public who are asking questions during the presidential debates. I'm only looking at the presidential candidates. And I use a convolutional neural network model to classify faces and to extract emotions. The model that I developed has a little more than 66% accuracy for 7 classes of emotion, which is kind of okay if you have so many classes. So it's not a binary model. It's a multinomial model. It has a lot of possible classifications. And the best model in industry, with which you can make a lot of money, has a 71% accuracy. So it's kind of close to that. There's a data set that people use as, this is like the basic data set that people use to train such emotional classification algorithms. It's called FER 2013. So this data set has 1,000 pictures of people and emotion labels attached to those pictures. Right? So that's industry standard data set. Of course, writing the code took a lot of time, but running the code took around 30 hours for me. So which is okay. Right? You can manage it. And I have the confusion matrix. So the confusion matrix indicates that happiness is very correctly classified in most instances. The hardest thing to classify is fear and being angry, right? Emotions of anger. The second thing that I did was extracting audio, emotions from audio. This was a little more complicated. Again, I used CNN, a deep learning algorithm, same deep learning algorithm that I used for image-based classification. This has a little lower accuracy, over 65%. And here what I did is I took audio files from the videos. I divided the audio files into 2 components. So one component is for foreground voice. One component is for the background voice, which we are not interested in. We are only interested in the excerpts of the files where people are talking, their voices. I looked at those files, and I created 10-second intervals in each file. I fed in those 10-second intervals into my algorithm and classified the emotion out of those 10-second files. Right? So this was completed in around 20 hours, thanks to Librosa, which is a really, really nice Python sound management library, which made things quite easier for me. Thirdly, I did emotion extraction from text. So I used a speech-to-text algorithm designed by Google, actually, so I didn't have to design that myself, which was kind of cool. But at the end, to extract emotions again, I developed my model, which again uses CNN, convolutional neural networks. and LSTM, long short-term memory, and neural networks, so layers of neural networks on top of each other. So this has a little higher accuracy, 69%. And to be able to match the audio file to the text file, again, I created 10-second intervals from the sound files, and I transformed the speech from those 10-second intervals into text, and then measured the emotion. This was quite fast. Developing the model was like 2 hours, and running the model was, again, 2 hours. So I guess the text data is the most sparse form of data when you have those 3 groups of data. The text data is the easiest one to deal with. So yeah. But one problem that I have here is I trained my data on things like this, right? So ridiculous. Greta must work on her anger management problem. Tweets, basically. And as you know, the way people write things on Twitter could be a little different than the way people talk in presidential debates. In terms of length, so when you look at 10-second intervals, when you do a text extraction, and when you look at 10-second intervals, the length is okay, right? Length is quite similar to the length of an average tweet, but the context could be quite different. But this was one disadvantage that I had to live with, because that is what is available as the industry standard. That data is available, so tweets and labeling of emotions associated with those tweets. And I had to develop my model on that because I didn't have a research team for me to develop that data set. So some side algorithms, so I had to do face labeling. Again, I used CNN. This has very high accuracy, over 99% accuracy. So I used 10 pictures of facial pictures from each candidate from different angles, kind of, frontal angle and from the sides. And then I fed those 10 pictures into my algorithm, and I extracted the faces from the video, and I compared the faces to the faces that I extracted. And based on a max voting principle, I decided which face belongs to what person. So this is, again, another 20 hours. Of course, you can run things simultaneously, which I did. So yeah, when you sum everything up, it's not a huge thing to run. Okay, let me talk about some methods for analysis, not the methods for developing the algorithms. So I used some dimension reduction algorithm to compare debates to each other. So each debate has a couple of, so when I did the emotion classification, I had one emotion category for each frame or each second or each 10 seconds, right? So when I extracted that data, I had to reduce that data into a data of means. So I found the mean sadness, mean anger, and mean fear, and mean surprise, and mean happiness, et cetera, from each debate. And I created a table like this that you can see on the top right. So for each debate, there's a percentage of some certain emotion that happens in that debate. And that is 5 to 7 dimensional data, meaning we have 5 to 7 different columns, which is quite hard to visualize, impossible to visualize if you have 5 dimensions. So to be able to visualize it, I used a dimension reduction algorithm that is called TSNE, T-distributed stochastic neighbor embedding, to reduce the dimensions to 2. And then I did some clustering with the reduced dimensions. I used cosine similarity to find which debates are similar to each other in terms of their emotional content, to compare those multi-dimensional debates and look at the distances between debates. So you can define, so distance is the inverse of similarity. So if you measure cosine distance, this means that you automatically measure the cosine similarity as well, which I did. So that's what I did to compare the debates, and I have the results in the coming slides. I also used some good old regression techniques like panel OLS, which didn't seem to be quite fruitful, at least at the moment. I did some correlation analysis, easy to understand. I compared distributions, did some network visualization, and some clustering that is done in many contexts. Okay, so here I have an example about what I did. Of course, you should take this example with a grain of salt, because this example, so this is, again, an emotion quantification example based on image. But the results may surprise you because the candidate is talking at the moment, And when someone is talking and when you measure the data, this results in some distortion because of the face movements. I cleaned that in my original data set, but for simplicity's sake, I have this example for now. So let's take a look at how the emotions of Mitt Romney changes in the third debate in 2012.
With the Arab Spring came a great deal of hope that there would be a change towards more moderation, an opportunity for greater participation on the part of women in public life and in economic life in the Middle East. But instead, we've seen nation after nation a number of disturbing events. Of course, we see in Syria 30,000 civilians having been killed by the military there. We see in Libya an attack apparently by, I think we know now, by terrorists of some kind against our people there. 4 people dead. Our hearts and minds go to them. Mali had been taken over, the northern part of Mali, by Al-Qaeda type individuals. We have in Egypt a Muslim Brotherhood president. And so what we're seeing is a pretty dramatic reversal of the kind of hopes we have in that region. And of course, the greatest threat of all is Iran, 4 years closer to a nuclear weapon. And we're going to have to recognize that we have to do as the president's done.
Yeah, okay, so this is an example. So what I did here is I extracted 4 frames from each second, and I did 1 second aggregation for emotions. So I looked at the ratio of emotions in every second throughout the video. Of course, this is probably not the best example, but the only one I have at the moment, because here I'm only looking at image-based emotion extraction. And also, if you watch the movie Mitt on Netflix, Mitt Romney himself says that his eyes always look angry because the structure of his eyes, he says, my eyes are like in caves, and people always think that I'm angry, despite the fact that I don't have the intention to show anger. Okay, so let's go to the next slide. So, okay, so if we go over the research questions one by one, the first research question was, are some debates emotionally more closely located to each other? Answer is yes. Okay, I did the some frames per second, image-based classification 10 second, emotion classification based on audio and text, reduced the number of dimensions to 2, and did some clustering and looked at the distances between debates on a physical space. So it turns out 84 debate 1 and 84 debate 2 are the most close located 2 debates, but that is hardly surprising because it's the same people talking in the debate. Which is a little more surprising is 2004 and 2008 debates as a group. And please don't ask me the reason. That's something that I hope to explore. Right? So I'm not sure at the moment why they are emotionally close to each other. And there seems to be a temporal trend. So if you look at decades separately, all the debates in the 80s are closely located to each other. All the debates in the 90s are closely located to each other. All debates in 2000s closely located to each other. Maybe people's emotions change over time, or their expressions change over time. They are getting updated. So this is the result of clustering, kind of hard to see. So here I have all the debates in 2 dimensions after TSNE. Here I have a clustering model with 2 clusters, so I forced them to be in 2 groups and looked at their distances. And here the third picture from the left, I forced them to be in 3 groups, and in the very last picture, I forced them to be in 4 groups. And again, compared distances between each debate. So this is what I did to further analyze the same thing. So I looked at emotions extracted from the text from each debate, and this gives me a lot of ratio values for each different kind of emotion. And then I looked how those debates are similar to each other by measuring the cosine similarity between each debate. So does the laser work? Maybe not. So if you look at this square, there's a legend on the right-hand side. So the lighter, as the color gets lighter and lighter, this means that the 2 debates are more similar to each other, right? So when you look at the square, and if you look at the lighter parts of the square, so you can see that there's a one square kind of lighter, kind of in the middle. So that is the debates from 88, 92, and 96. which means that the text emotions from those debates are similar to each other. And then we see another light area to the bottom right part of this square matrix, which again suggests some similarity for the debates between 2008, starting from 2008, going through 2012 and 2016. So those debates are also similar. If you look at audio emotions, it is less similarity, but still there are some debates that are similar. There are some light instances, light squares within the large matrix. So again, we see some similarity for 84 debates, 96 and 2000, 2004 and 2008, 2008 and 2012. And this is for image emotions. And here, the strongest similarity is between 2008 and 2012. So what does this say? If we want to summarize this, the least difference we find in text emotions, the second least difference we find in audio emotions, the second least difference we find in image emotions, and the third least difference we find in audio emotions. So what does this mean? People say something, but actually their emotions give them away, right? So what they say emotionally doesn't evolve a lot, change a lot over time, but how they look and how they behave changes, right? It's not similar to how other people behave. So they actually communicate, if you can say that, if you can force that statement a little more, they actually communicate more strongly through audio and image than they communicate through text, if their goal of communication is projecting emotions, right? If we can assume that. Did the role of emotions change over time? Yes. So I again looked at the ratios of emotion classifications here in each debate. And this is probably the most important graph that I produced that looks at the ratios of emotions in each debate, starting from, can I get rid of this? Probably not, bar. So starting from 1976 going through 2016. And if we fit some trend line into that graph, we get this graph to the right. So I looked at neutral emotions on one hand and combined every non-neutral emotion as the rest of my analysis. And the ratio of neutral emotions, if you can see, for everyone, which is shown with the green line, was around 45% in 1976. And it decreased a little bit over time, so now it is around 25% in the 2016 debates. If you look at Republicans and Democrats separately, Republicans have become a little more emotional than Democrats did over time, but still, both for Democrats and Republicans, the amount of non-neutral emotions are on the decline. Do presidential emotions have an impact on elite and public perception? I couldn't find any evidence. So I did sentiment analysis for some comments on YouTube, ran panel OLS, and I have the results in the coming slides. No effect. Right? So I looked at endorsements of people, and I set up some regression models that look at the amount of emotions and the amount of endorsements for each debate using a panel regression. And I also looked at YouTube comments extracted from the times when the debates took place. I did some sentiment analysis on these YouTube comments and looked at whether people have become more positive after the debate or have become more negative after the debate. Not a strong relationship. Some very surprising results. Everything is zero, right? So I ran a couple of regressions. I looked at the percentage of votes that the winner candidate received, that the runner-up candidate received, and I looked at the difference between winner and the loser in the elections. And I looked at the party difference, and then there seems to be no impact between emotions and all these possible combinations of dependent variables. Okay, so my network question, from a network perspective, can we say that there were some debates that were more influential than each other, right? If some people watch one debate, are they more likely to watch another debate, and does that make that other debate more influential? Again, I extracted the YouTube comment data from the most viewed debates for each presidential debate on YouTube, set up a network, And it turns out that the debate that's been watched the most number of times is Obama-Romney debate 3 and Obama-McCain debate 1 and Obama-Romney debate 2 as well. So you can see those in the left-hand side network with larger bubbles, larger circles. And if you do network clustering, again, if you want to group those two debates in terms of their similarity, in terms of which people watch them, you can see that we have a group of Obama-McCain people. So those people, if they started watching the Obama-McCain debate, they continued on watching debate 2 and debate 3. And not so much evidence for the rest of the crowd. Okay, so if we transform the same data into numbers and look at the common connections between debates, so this means how many people watched the debate on the left-hand side and the debate on the right-hand side. So it turns out that 89,000 people watched Obama-McCain debate 1 and Clinton-Trump debate 2, right? Watched both of them. And 35,000 people watched both Obama-McCain debate 2 and Obama-McCain debate 3. Is this the end? Oh, okay, I don't know what happened. Some descriptive statistics looking at debates. So I have line charts for different debates. If you're interested, we can go back to them. You can see that there's a lot of up and downs, in emotions. This is because candidates speak in turns, right? They don't speak continuously. And also, it's all a matter of aggregation. If you want to make the data a little more smooth, you can aggregate things by 1 minute, 5 minutes, 10-minute intervals and relook at things again. So yeah, I'm not sure what's going on. I did some descriptive analysis on the correlation between different emotions. So this is, the left one is 1984 debate 1, the right one is 1984 debate 2. So basically what I tried to look at here is if you show some signs of some emotion, right? For instance, if you show signs of anger, are you more likely to show signs of another emotion like surprise? Right? So this is what I did. I think the interesting takeaway from these pictures, these graphs, is that are Democrats and Republicans similar to each other? If you don't see them in separate groups, right, which is kind of the graph on the left-hand side, this means that they are kind of similar to each other. If the dots on the graphs are on top of each other, this means that they are similar to each other. So on 1984 debate 2, they weren't so similar to each other, right? The emotions that they show. And this is for 1992 debate 1 and 1992 debate 2. And you can see that there is, again, some mismatch based on the distribution plots that you can see in the diagonal. And again, this is all something that I should explore and discover. I'm not sure why. Right? Why are they showing different emotions? Something to think about. Okay. 2004 debates, they seem to be pretty well aligned in most cases. And again, the graph that we took a look at a couple of slides ago, ratios of emotions over time. And if you accumulate emotions over the base, so this gives some other interesting result, right? So the surprise emotion dominated some debates, like 1976 debate 1, 1992 debate 2. Neutrality was the dominant emotion, and in 2016 it was competition between fear and being surprised. Right? So this is the number of instances that you see throughout the debate. How many times you see a person angry, disgusted, happy, and if you accumulate everything over time. Okay. I think this is I have 2 more slides, I think. So this is again the emotion graph that we looked at. Neutral emotions are on the decline, non-neutral emotions are on the rise. Clustering results, to take a look at them again. So you can see that some debates are more closely located to each other, and those debates are 80s debates and 2000 beginning of 2004 and 2008 debates. Okay, so what are my key findings? Over time, emotions have become more prevalent. Non-neutral emotions are on the rise, right? Neutral emotions are declining. The impact of emotions on elite and public perception is questionable. I couldn't find evidence, although this was the most difficult part of my analysis. So I had to transform and collect a lot of data for endorsements. It wasn't fruitful. It's possible to group emotions temporally. Probably people change over time along with emotions. Right? People's emotions change over time. And it's possible that there's some correlation between text-based, image-based, and vocal emotions, so audio-based emotions. So this correlation is much stronger between image-based and audio-based emotions, not as strong with the text-based emotions. Right? People say similar things, have similar emotions in what they say, but how they behave and how they express those things is different. Okay, so what can I do in the future? Flag from House of Cards. So what I'm planning to do in the near future is doing a topic analysis with this research and add a natural language processing component to this research. So what I am doing at the moment is I am classifying components of each debate by using an STM and LDA model to do some topic modeling and try to extract whether there's some correlation between different topics that people talk about in presidential debates and the emotions that they show. Second thing that I'm interested in is how people respond to each other's emotions within the debate. So that's something else that I'm working on. If one person for instance, shows signs of anger, does the other person reply with signs of anger? How does this differ from party to party? If a Republican is responding to a Democrat, vice versa, or if a Republican is responding to a Republican or Democrat to Democrat. If I am successful with this, of course, I would probably like to take this a couple steps further and do a cross-country analysis by looking at candidates from other countries. Are they, would that give similar results to what results we have from the US case? Statistical significance. So I want to collect even more data from the debates, meaning I want to extract more information from debates if I increase the granularity in the debates. So if I don't aggregate everything by one debate, but analyze things separately within each debate. And if everything is very successful, and this is a success story, which I'm not sure, I want to do a dynamic web application of this in the future. And at the moment, I am writing a paper on democratic debates of 2016 and 2020 as well, which is similar in methodological structure, but the results could be drastically different. This is my last slide, so thank you very much for listening. Thanks for coming.